Okay, we're going to look at the proofs that we promised in the last video about some of the remarks we made about groups. So we're going to prove that the identity element is unique, we're going to assume we have more than one identity element. So we're going to assume G has two identity elements. E.g., E capital G and small g. Okay, and then we're going to look at what the consequences of this are. Alright, so the fact that E.g. is an identity, well, that implies that E.g. star E little g is equal to E little g, because the way identity elements work, when multiplied by an element in the group, they just keep it the same, okay? But then the fact that E little g is identity, that implies, and we'll do the multiplication the same way, E.g. star E.g. equal to E big G. And that's because, again, multiplying from the right by an identity still keeps the same. So this clearly implies that E of big G is equal to G, which contradicts that EG and E of little g are not equal to each other. So therefore we can't have more than one identity. Okay, we must have one singular identity element. Hopefully this makes sense, and then we'll change colour for our next proof. Now we've got a similar idea. We're going to get at y1, y2 inverses of x and g. Okay. Then we're going to use our laws of groups to rearrange this again to show that y1 must be equal to y2, and therefore we can only have one inverse of an element x and g. We know y1 by the laws of group file identities is equal to y1 star the element. And then we know by the definition of y2 being an inverse set, the identity element, okay, is equal to x star y2, okay, because if this isn't true, then y2 is not an inverse, and that's the assumption we're making. And then we've got the associativity property, so we can write this as y1 star x y2, and then again by the definition of the inverse element of x, y1 star x is the identity star y2, and that's clearly equal to y2, and y1 equal to y2, and inverses in a group must be unique. So these two proofs are pretty simple, follow similar ideas, and also it's a good introduction to proofs involving groups in general. We're just using the properties of the group to say what we can say about these things and working towards what we want to prove. Okay, so we're going to look more at groups in the next couple of videos, maybe some examples of some more interesting groups as opposed to the integers and stuff. We'll look at some matrices and permutations perhaps. Now that's it. If you have any questions, let me know down in the comments. If you enjoyed this video, please be sure to like and subscribe. I hope to see you in the next one.